Wait, we have this on our paper, don't we?
No, you have a spot for it. You need to, I'm telling you.
We have this on our tablet.
Yeah.
Sorry.
Yeah, but on your blue sheet. The blue sheet they used on the test?
Did you say get it out?
Yeah. Bunch of slackers.
Skipped, because they got there.
Well, you guys do know that I'm recording and they're going to hear you call them bums, so.
Yeah,
Wait,
I missed
right.
your coffee.
Were you recording?
I was.
Whenever I walked in and said, who are
No, I wish I would. No, I'd stop then. But
Are you recording right now?
I am. I'm going to. So the product rule says that you take the derivative of the first part times the second part, and then the derivative of the second times, or well, first times the derivative of the second plus the second times the derivative of the first. So let's look at example A. So we take the first part, which is just 2x minus 1, times the derivative of x minus 4, which is what?
1.
1.
Whoa. Huh?
And then plus the second part, which is x minus 4, times the derivative of the first part, which is 2. So I brought down my first part, right? So this is in two parts, right? So let's do blue and green. So I brought down the first part as it is, and then I took the derivative of the green part, right? So I'm using my power rule. So the derivative of x is just 1, and the derivative of negative 4 is 0, so it goes away. So we're multiplying it by 1.
Okay. Are the negatives always just 0?
Any number without a variable is just 0.
So we did the power rule.
Doing the power rule, right? The power rule is just how we take derivatives now.
Okay, so we're not even worried about that limit
No.
for derivatives.
Nope. Good to know, but we're power ruling all the way through.
That's all we're
Power within.
Well, okay. Hush. Now you just bring down the green part. And then you're taking the derivative of the 2x minus 1. So just 2. So then now you're going to multiply and combine and be done. So the first part will just stay 2x minus 1 because you're multiplying by 1. And then you're adding 2x minus 8. So you get 4x minus 9. Yeah. Right, so before when we did these, right, we would have foiled this and then done the power rule. Right, you can still do that, but honestly, this is faster. Because, like, look at the next one. That's going to be it's going to be way easier to just do it this way than multiply all that together first and then take the derivative.
The problem is, I don't remember. I do remember, but I don't know.
Tell me you got the yellow part again.
I did the multiplication, so I just did 2x minus 1 times 1, which stays the same. And then 2x minus 8.
Are you the teacher?
Hey,
I didn't think so.
you two quit bickering like 5-year-olds. It's been going on for weeks, and I'm tired of it. Now you're all looking at each other like a bunch of kindergartners. So, 2 times x, and then 4 times 2. Just distributed my 2 through. Shay, you turn around one more time. I don't know what I'm going to do, but I'm going to, like, make you put one of the dividers behind your head so you can't look at Briar anymore.
She just give me a demerit.
I should.
Honestly, I'd take that demerit just to look back at him again.
Okay, number 2. All right, so we have the first part, which is we just bring it down. So x squared plus 3x minus 1 times the derivative of the second part. So what's the derivative of 2x squared?
4x.
That's it.
4x is a salt, a hydrated borate of sodium.
What is happening? Like, what's funnier is I thought it meant like assault. Like, 4x is like assaulting somebody.
It said 4x,
Oh,
not 4x.
I heard 4x is assault.
Yeah, 4x
feel like-
is a salt.
Yeah, all right. I gotcha. But we need to write 4x is assault on the quote board.
I'll write it, then Amelia will.
Okay. All right. So then, all right, now we take the second part, which is 2x squared minus 5, times the derivative of that first part, which is what?
Hold on.
2x plus 3.
Should I say that Siri said that or that you said that?
I need a quote.
5x.
Give it to me.
Whoever.
Oh, no.
Huh?
Me, Siri, Daniel, all three of us are involved there.
Wait, I can't do that derivative one.
What?
Never mind.
Okay.
Oh, we're gonna have to foil.
Yes.
Are you serious?
Welcome to math class, guys. This is like foiling's just a daily thing for us at this point. Or it should be. But okay, so we're going to take that 4x and distribute it through to the first part. So you get 4x cubed plus 12x minus 4x. And then you get 4x to the third plus 6x squared minus 10x minus 15. Then combine like terms. So 12 minus 4 is 8, minus 10 is negative 2x. Oh, hold on. I'm going to move that over. I'm going to bring down my plus 6x squared first. Right, so then there's our derivative.
Okay.
Wait, I got 18x squared.
12 minus 4 minus 10. To minus 10x.
Oh, X minus 4.
So it'd be 8x squared.
Oh.
Is the 12x the first 12x after the 4x cubed? Is that not squared?
Oh, it is, which messed up my entire thing. Hold on. Thank you. So then that is an 18x.
Oh.
So 8x cubed plus 18x squared minus 14x minus 15. Sorry. All right, let's look at example C. Okay, so we have sine and cosine. All right, so the 2 is really going to go with like each of these when you do it. No, Brian, I mean like when you're doing the, technically we can just do 2 and then do our product rule here. And then you can just leave it. Yeah. All right, so it's the first times the derivative of the second. So what's the derivative of cosine? Plus the second, which is cosine, times the derivative of sine, which is cosine. So it's 2 times negative sine squared x plus cosine squared x.
I didn't understand that.
Why?
My brain doesn't work like that.
Right, so we just brought down sine x, took the derivative of cosine, which is negative sine, and then it's the second, which is cosine, times the derivative of the first, which is the derivative of sine, which is cosine.
Oh, okay, I got you. It's like the other ones again.
Yeah, it's just like the other ones. Same process. It's first times the derivative of the second, plus the second times the derivative of the first.
We're just leaving it like this.
Yeah, you can leave it like that.
Oh.
All right, so now we got this one.
Is that it?
For C, yeah.
Oh, that was simple.
That's all you can do. Huh?
Splendid. Extravagant.
Still like the root.
All right. So,
Elegant.
now we had this one. So it's our first 3e to the x minus x squared times the derivative of the second
3x
squared.
squared.
Yep. Plus the second times the derivative of the first, which is 3e to the x minus 2x.
So the 3x just stays the same. That's really.
Yeah, the 3e to the x will stay the same.
Hold on. How is the derivative of the first one 3x?
Because
3x squared?
Oh, wait, never mind. I see it. I see it. I will.
No, you're not.
No, I'm not.
All right. And honestly, since you've got all kinds of weird exponents and stuff going on in here, I would just leave this like this. I'm cool with that.
So less work is better.
Yeah.
Sounds good to me.
Yeah, because you're not really going to be able to simplify this any further. It's just going to get messy. And there's no point. So leave it here. All right, you ready for the quotient rule?
What?
Are you ready for the quotient rule for things that are divided? Product rule, that's it.
I guess.
So, is there ever going to be like one where it's like 3 things,
Not at this time. Eventually, yes, but not today.
but not?
Never mind, I'm not going.
also look at my full syringe pen.
Is there
Weird
black
how we
bar
have
in there?
stuff.
Miss Huffman give you guys that?
No, we
Oh.
got it at Spirit. I mean, I got it at Spirit Halloween.
Oh, okay.
I forgot that I had them until now.
I was going to say, because somebody else had one in class today.
Bar in there.
All right, so just remember, though, that it's not just, if you have two things multiplied together, you can't just take the derivative of each and then combine, right? You have to do that product rule. Okay?
The next one looks a little bit more difficult.
Yeah, the quotient rule is a little more,
Work.
yes, not too much work. It's basically like the product rule on the top, and then you got to do some other stuff. All right, so for your quotient rule on your blue sheet.
Do we
Da-da-da-da-da.
write that other one for the product rule?
Yeah.
Yeah, you should call this a people.
House probably. No.
Yes.
What, Shay? Why are you throwing your hands up?
Because now I'm too
They're
early.
sweaty.
Bar's calling people little boy.
Yeah, Shay, let them hands
When
go
he
out.
was a little boy over there.
You two? Quit.
That's an air.
This one is the bottom, so it's x minus 5. So, we're going to start with example A here. So, we're going to do the bottom, which is x minus 5, times the derivative of the top. Oh, derivative of the top. What am I doing? Not taking the derivative. So 3x squared, 6 x squared.
Whoa.
Sam, why does anyone listen?
Why do we listen to Sam? So 6x squared plus 8x. Right, and then it's minus the top times the derivative of the bottom, which is just what? No? 1. So it's just minus 2x cubed plus 4x squared minus 7. Divided by the bottom squared.
So, I think it's, so how is g of x just x minus 5?
Because that's what's on the denominator. So, like, they, in the example, they're saying, like, this is what they're calling f of x.
Oh, okay. So
G of
this
x.
is that in the brackets?
Yeah.
Okay.
So that just means, like, top and bottom. Yes.
Wait. So on that second part, right? Because I was writing down. So, I understand that that's f of x, or f derivative of x, whatever. And then g of x.
In this case, it would be just be the
It
bottom.
would just be 1.
Yeah.
Okay. Thank you.
Yep. So then on top, we can multiply and simplify. Right. So that gives us 6x cubed plus 8x squared minus 30x squared minus 40x. Ew, I did not leave myself enough room.
Yeah, this takes up way too much room.
Oh, you're fine. And then, I'm annoyed.
Minus, wait, do we minus?
Yeah, and then you're gonna, hold on, I'm gonna write this down here.
But then you can.
So then you're subtracting the top. So it's minus 2x cubed minus 4x squared plus 7.
Is that just continued at the top?
Yes, I just ran out of room.
Well, we gotta put in the negative anyway.
So then you get 4x cubed minus 26x squared minus 40x plus 7 over x minus 5 squared.
Are we going to square x minus 5?
No, you can leave it here.
Okay, minus
Oh,
40x.
okay, I don't read that.
Plus
Sorry. What's it say?
26x squared minus 40x plus 7.
Plus 7.
Yep. All right, how do we feel? Okay,
Is that all?
that's it for A.
Oh, okay. Yeah, it's not that. These ones are like, they're just plugging in.
Yeah. Now that you guys have the power rule down. All right, so
Oh, man.
okay. So then for B, it's the denominator times the derivative of the top. So what's the derivative of e to the x?
1.
E to the x minus the top times the derivative of the bottom, which is what? Good. All over x squared plus 1 squared. Yes. So since they both have an e to the x in common, we can just like factor that out. And then that leaves us with our x squared, our 2x, and our 1.
What did you just do?
I factored out e to the x. Yeah, like they both have it in common. So I just brought it outside, and that just left me with these things, which I put over here. And I just put them in descending order because it looks
But-
prettier.
Isn't that technically a negative EX?
Yeah.
And a negative
Oh, because that's a minus 2x then. Sorry. That's my bad. Yes. So then it's a minus right there.
It's the E not minus.
Why is the E not minus?
Because we're just pulling it out, so then that 2x gets the minus. The minus will stay with the 2x.
Oh. But if you left it in there, wouldn't it cancel out anyway?
No.
No?
Then if you like multiply it back in, then it'll still be there. And then And then, yeah, I'm good there. This lady's very inconsistent with how much she reduces stuff, though, and I don't like it.
Who is?
The lady that made this curriculum.
what do we name her?
I don't know. I've been calling her Brenda.
Brenda, it was,
Brenda Webb.
No, no.
we named that lady, I think it starts like a D.
The lady that made the
Delma.
videos. Delma?
Delma.
Oh,
Yeah.
Is
well.
she the one that made the curriculum?
Yeah.
Delma, do you remember?
I don't know. Either way.
Yeah, that's what Dave named her after. Delma.
Alright, so let's do this one. So the denominator is times the derivative of the top
1 over x.
minus the top times the derivative of the bottom, which is just 1. And then it's all over x minus 2 squared.
Why didn't you write Tom?
So then rather than leave that fraction in the top, if you multiply everything by x over x, that gives you x minus 2 minus x ln x over x times x minus 2 squared.
Why'd you do that?
I did that to get rid of this fraction of 1 over x in the top, so we don't have a fraction in a fraction.
Okay.
How are we gonna know to do that?
Well, this is me teaching you to know how to do that, Briar.
Yeah, but I just won't.
Is that the answer?
Yeah.
So that just makes that one, the fraction go away?
Yeah, because look, I multiplied it by x, which makes the x, like, because this is all multiplied together, so if I just multiply it to this, I'm good. And then the x goes here and here.
How do I get a password to my Facebook account?
How do you make it?
My mom asked me I need the password to your Facebook account, but I've never even done anything with Facebook.
Did you make a password? Then you don't
Maybe
have
you
a
should-
I don't
password.
have an account.
You don't,
Made it.
you don't have an account, you can't have a password.
Yeah, no, I don't know.
Why not?
Letter D. So,
Cosine.
denominator is 1 plus cosine times the derivative of the top,
Cosine.
which is cosine, minus the top times the derivative of the bottom, which is negative sine x, divided by 1 plus cosine squared.
That's it.
Nope,
We're not done.
we're not done.
1 plus cosine squared x minus sine squared x.
All right, hold on. Plus sine squared x, because you have two negatives.
Oh.
Who remembers our trig identities?
No.
What now?
Not me.
If you give me a minute, I'll get there, okay? I'm trying to write down everything else though.
Wait, how did that become?
What sine squared plus cosine squared equal?
Tangent.
No!
I don't know
Cosine
what that
squared.
paper is.
No!
45.
No!
Cotangent.
Hold
No.
on, I'm getting there.
I don't know.
Secant
Wow.
squared.
Cosecant.
1.
1!
Oh.
Don't do that though.
Haha.
So, we can simplify this because sine squared plus cosine squared on top is equal to 1. Wait, what?
That's 1 plus 1 on top.
Oh! No.
No.
Because I messed up. So you distribute this cosine, so it's cosine x
Whoa.
plus cosine squared. I messed up. Listen, Shay. So it should be cosine x plus cosine squared plus sine x.
Oh.
Yes.
Alright.
All right, let's start. So 1 times cosine is cosine. Cosine times cosine is cosine squared. Sine times sine is sine squared. So yeah, this is still 1. So now on top we have a 1 plus cosine x.
Wait, how is that on 1 again?
All right, because sine squared plus cosine squared equals 1. Always. That's not a tangent.
Trig.
That's an identity. Yes.
Trig identity, okay.
So we just know that. Shane, Sam, quit talking. Pay attention. No, just right. So then we can cancel that with one of these. So you just get 1 over 1 plus cosine x. Because I said that cosine squared plus sine squared is equal to 1. That's what trig identity. We learned it last year.
Yeah, it's a big
That's
program
what
stuff. Last year. That was last year. Okay. Makes sense. Like,
Was last year because we take pre-calculus before calculus. Memorize them. I should make you, but you should really at least know sine and cosine.
Oh, yeah. Sine is.
Sine is cosine, cosine is negative sine.
Cosine's negative
Yeah,
sine.
you guys have these, but let's write them down anyway. So, derivative of sine is cosine. Derivative of cosine is negative sine. I scrolled down a couple pages. Tangent is secant squared. Cosecant is negative cosecant times cotangent.
Wait, why'd you put theta on some and x on some?
Because I don't know. What was that?
it's
What
nothing.
is wrong with the phones today?
I don't know.
Nothing
Is that
is
your talking
wrong.
tone? Remember
Why
mine
won't-
was
it won't let
from
me
church
draw?
sometimes.
Please let me draw.
Oh,
I'd like to draw.
Did anyone else talking tone go off?
I never had a talking tone.
never got into the talking tom when I was little.
Talking Tom.
I
Oh no.
loved it.
Really?
When you like
Just
hit
wait a
it.
minute, it won't let me draw.
Ask my question, what?
By the time I was old enough to have
You
a
could
phone,
hit
I
it
didn't
and
have
you talking
that.
tone.
Ask her a question.
Okay. Yeah, I'm just gonna do this
You know when
real
you
fast.
hit it and say,
Like this. Equals cosine. Cosine.
Oh, they can start moving and asking questions.
Yeah. It's squared.
Ellie, what is it?
It's my
Oh,
mom.
stop
I
it.
can't silence my mom.
Oh, tell her you're in calculus.
I'm
Can you not put it on silent?
no, because my mom is the one person. Okay, she's my emergency contact.
Here are a couple of these derivatives. Yeah.
Okay.
All right, so this one you can rewrite this as x minus 4 to the negative 1/2, right? And then you can do that power rule still. So you can just do negative 1/2 times x minus 4 to the negative 3/2. Oh, I scrolled too far. Right, so then you just rewrite that as negative 1 over 2x minus 4 to the 3 over 2.
Do you mind to change the color from
One
the next
half.
one?
Yeah.
Negative 3 over 2.
Is that just that? What we just did with the derivative?
That better, bar?
Yeah, thank you.
Yes. Yeah, we took the derivative.
Oh, that got it awfully large. Should we simplify? Do we need to simplify that bottom or not?
Nope. You can leave it.
I feel like I'm breaking some math rules because I've been told to go simplify stuff.
I mean, you can't. You're just going to change what it looks like. It's not really simplifying it, though. Technically, we did the simplifying to go from here to here. We got rid of the negative exponent. The other two we pretty well have already done. You just change it and simplify it before you do it. We'll talk about higher power derivatives tomorrow. So I guess you guys get no homework tonight. Congratulations.
Aww.